Let's pick up the particular case wherein we are putting in our charge in a magnetic field wherein they are mutually perpendicular to each other. That is the velocity. So velocity and your magnetic field are perpendicular to each other. That's the case. So our funda over here is to figure out, we know that it goes in circular path. So what is the radius? And what is the period of revolution? Because it's going round, it'll come back to a certain point after a certain time every time, given everything else is constant. So we are trying to figure out how much time it takes to go around. So let's consider a positively charged particle moving in a uniform magnetic field with the initial velocity vector of the particle perpendicular to the field. Let us assume that the direction of the magnetic field is into the page as shown in the figure. I think, did I mention about moving in a uniform? So if it's clockwise or anti-clockwise, so in our case, we are doing that. We want the magnetic field inward. So it has to be anti-clockwise. Then, oh yeah, this has to be, we have done this before actually, but I forgot. Only then this will be, force will be inward. Consider a positive charge particle moving in a uniform magnetic field, so on and so forth. Okay. So here we are moving it, making it move from right to left. The charge is moving from right to left. For this diagram. Okay. Yeah. So what is that we're looking at? We're so we're looking at the radius first thing first. Radius. Radius of the circular path. So let's start off with writing the obvious. So what do we have? On a charge Q, moving with velocity v. So when it encounters or when it enters a magnetic field at a right angle, right? Then force will be equal to Q VB. So this will be equal to literally Q VB because sine of 90 is 1, right? So we have written everything else. Now we are trying to look at the radius. How can I relate this to radius? I can't do much with our right hand. I can do something with our left hand. So let's substitute force is equal to mv square by r. So we have the r over here. But where did I get this expression? From, yes, centripetal force. Okay. So we have mv square by r, which is equal to qvb, guys. So why is that we are able to equate? We'll also write the reason. Because the resulting force acts like a centripetal force always perpendicular to the moving charge. With all of these reasons, we are able to equate this to. Okay. So V and V will get cancelled. R is equal to mv by qb. So from this, what can you guys conclude? So conclusion for this, that the radius depends on the mass of the particle, velocity with which it's moving, the charge of the particle, and the magnetic field strength. Right? You guys can talk about that. R depends on I mean, it's kind of commonsensical when you look at it. It's very clear. Next is time period or time of revolution, right? So this is your radius. So how much time will it take to go round and come back to point A, for example? Will we do this? How will we find the period of revolution? What can we do? We can make use of time is equal to, yes, the very famous formula, distance by speed, right? How do you find the distance? Distance is nothing but 2 pi r, circumference of the circle, divided by speed is v. Agree? But we know from 1 that r is 2 pi by v mv by qb. So this is from 1. So v and v gets cancelled. And what do we have? 2 pi, just a second, 2 pi m by qb. And that's the time taken for 1 round. And the frequency for this will be qb by 2 pi m. So within 1 second, you'll be able to go around the circle this many times. So many hertz. And this is so many seconds. What is that we can conclude from this? This conclusion is pretty important. It does not depend on the radius. Right? It does not depend on the velocity. What it depends on is the charge and the magnetic field strength and the mass. So it purely depends on the charges, internal property, and the magnetic field. Okay, that's the conclusion that I want you guys to write. It's independent of velocity that it comes in. Okay, so that's pretty important. And it depends on intrinsic property of the charge and the magnetic field strength, right? Intrinsic property of the charge and the magnetic field strength. Okay, so very simple derivation. So all we did was equated our known formula with the centripetal force, and we got the expression for radius. Once we have that radius, we can find the time period. So time taken to go 1 round. Okay, yes. So now you can pause and have a look. So such conclusions are pretty important when we're dealing with conceptual questions. Don't take it lightly. Now we'll not see the importance, but as and when you use it in your tougher numericals, you will understand. Conceptual questions, you will understand that they play a role.